Hello friends, this is the fourth part of the video for the enzyme, and this is my link for my website where you can find some more videos, and this is the link for my YouTube channel. You can go and watch some more videos. You can subscribe my channel, you can leave comment and your suggestions. You can always give me questions. Hello friends, this is the fourth part of the video for the enzymes. This is my website easyscience.weebly.com. You can find some more videos here, and this is my YouTube channel where you can see more videos, and you can leave your comment, and please subscribe my channel. So now straight away go to the enzyme where we were, and what we did in the last video, we showed that how the substrate concentration can be very lower amount from km. We saw three conditions where the substrate concentration is much smaller than the km. The next condition was where km value is much lesser than the substrate concentration, and the third one is the km is equal to the substrate concentration. In these three condition, what kind of reaction will happen, the order of the reaction, we have discussed everything. Now the thing that we want to discuss now is this: what is the steady state level of the enzyme substrate complex? Now if we draw a graph like this, and this is my enzyme concentration that I'm starting, this is my substrate concentration, sorry, this is my product concentration that I am drawing in this way. This is the time in according to the x-axis, and the quantity, this is the quantity, and so this is the p. Now let me change the color, and let me take a new different color. That this is the s. Why it is increasing? Because p is p is getting produced, and the substrate concentration is increasing with decreasing with time, because the substrate is getting used. Now as I give the enzyme and substrate to get together, the first reaction that takes place, and that happens at a very high speed, is the ES formation, and it will start from the zero level and it will increase a bit, and then it will be maintained in a steady state level. This is the enzyme substrate complex graph line, and this is the steady state. Now what happens at the equilibrium condition? If we write the equation like this, that this is the enzyme, this is the substrate, the enzyme substrate complex formation constant is k1, and the reverse reaction, the constant is k minus 1. This is getting formed. Now there is another constant which is k2, and the p is formed, and this is the free enzyme that will be released from this enzyme substrate complex for the new reaction. Now this, according to this Michael-Menten's equation, this ES formation is very fast, and it maintains a steady state level. That means the production of the enzyme substrate complex and the dissociation of the enzyme substrate complex into the free enzyme and the substrate is same. So the forward reaction and the reverse reaction is same. You can also write it in this way, that the rate of reaction constant are equal. So the enzyme substrate association and enzyme substrate dissociation, the rate is similar. So this enzyme substrate concentration maintains a steady state level after some amount of time in the reaction, and then this enzyme substrate complex again produces P in this direction. So with time this P will be produced, and with time this substrate concentration will be reduced. So the graph is like this. Now in the next slide we can write one thing is that if the enzyme attains the maximum velocity, that is the v, when it has reaches the maximum velocity, that means all the enzyme has formed this enzyme substrate concentration. Now you can denote this all enzyme as ET. That means all the enzyme molecule present in that reaction is now engaged, it is now working. Alright, this ET is denoting the total enzyme concentration. You can write it in this way, that maximum velocity is equal to K2 ET. So when once the enzyme has reaches its maximum velocity, there is no opportunity. Why there is no opportunity that the enzyme will increase its velocity? Because all the enzyme molecule is now engaged. And how you can define this Vmax? It is K2 into ET. Now what is this K2? K2 is ET by Vmax, and the K2 unit is per second. You can write it in this way. The constant K2, the unit of this constant is this, per second. Okay, now the thing is that if the substrate, now how we write this thing, that V is equal to V max into substrate concentration by Km plus the substrate concentration. Now we know that V max is basically this K2 ET. Now when the enzyme concentration, we can replace this thing, that V max, this is the V, and V max we can replace it with K2 into the total enzyme concentration. You can write it in enzyme concentration, you don't have to write T, and this is the substrate concentration, and this is the Km plus S. Now when the substrate concentration is very low, you can always ignore this part, this Km plus S. Okay, let me make some space for you so that I can write down here somewhere. Okay, I guess this portion is fine. Now we can write. The thing is that let me take a pen here. Okay, this is my pen. Alright, so we can from here we can get this small v is equal to K2E, that concentration. We know that this V max is equal to K2 total ET, and this is the total enzyme concentration I have written here, and this is my substrate concentration. Now if the substrate concentration is very less, you can always ignore this portion. Now how you can write this equation? You can write this equation in this way, that K2 enzyme concentration into the substrate concentration by Km. This is the format. Now this one itself is another constant. Now I am taking another page, that is this K2 by Km is another constant, and this is a specific constant. means if with this constant you can measure the efficiency of an enzyme. K2, the higher the K2, the rate of the production of the product is high, and the lower the Km value means the higher the substrate affinity. So this ratio of this K2 and Km gives you a clear hint that how much good an enzyme can be. That means according I mean regard if you take the efficiency of the enzyme in our discussion, then K2 by Km gives you a hint that how much that enzyme is efficient.